So these are optional notes. And there are a couple things we need to remember. The tangent of x is the same as the sine of x over the cosine of x. The cotangent of x is the same as the cosine of x over the sine of x. Secant of x is the same as 1 over the cosine of x. Cosecant of x is the same as 1 over the sine of x. And the cotangent of x is also 1 over the tangent of x. So let's say we're trying to take something like the antiderivative of 1 over the cosine squared of x with respect to x. We don't know how to deal with squareds right now, but we do know that 1 over the cosine of x is the secant of x. So 1 over cosine squared is the same as the secant squared of x dx. This is where it's really important to have our rules memorized, because this is only helpful if we remember right off the top of our head that the antiderivative of secant squared x is tangent of x plus c. Just something we have to know. When we do our check step, and secant squared goes back to 1 over cosine squared. Similarly, let's see, that was our first problem. This is our second problem. Let's say we're doing the antiderivative of the cotangent of x times the sine of x. Sometimes we can just play with these to get them to be nice and neat. So if you remember that the cotangent of x is the same as the cosine of x over the sine of x, those just cancel out, and we're left with the antiderivative of the cosine of x. That's where we can use our little circle. So cosine of x was over here. We're going to go back where it's to sine of x. And there we go. When we check it, the derivative of the sine of x is indeed the cosine of x, and we just look back here to make sure we've done this right. Sometimes we can even get the trigonometric functions to go away entirely. So let's say we're trying to do the antiderivative of the tangent of theta times the cotangent of theta. Remember, theta is just another variable. Well, if we use this rewrite, we can say this is the tangent of theta times 1 over the tangent of theta. Those cancel out. This is just the antiderivative of 1. And so this is the same as the antiderivative of 1 times theta to the 0 power. So just like we would do with any other variable, we're just going to add 1. That's theta to the first power, 1 times theta to the first power over 1, or just theta. Then when we go the other way to check it, the derivative of theta with respect to theta is just 1. It's exactly what we had.